Imagine two groups of athletes running on the exact same basketball court for the exact same amount of time.
Right, doing the exact same physical work.
Exactly. They are sweating the same, breathing just as hard, and covering the same distance. But at the end of 8 weeks, one group has built this explosive, injury-resistant leg strength, and the other group hasn't gained a single ounce of power.
It's wild.
It really is. Welcome to the Deep Dive. Today, we have a mission that feels, incredibly relevant to anyone listening to you who has ever tried to optimize a workout, master a new physical skill, or really just structure a learning routine.
Yeah, because we're looking at how a remarkably simple change in the rules of a training environment can fundamentally alter human biomechanics.
Right, and neuromuscular adaptation, which we'll get into. And we are pulling our insights today from a beautifully designed piece of experimental research.
A phenomenal paper, honestly.
Yeah, so the source material for our deep dive today is a 2024 article published in the Journal of Sports Science and Medicine. It's titled, it's a bit of a mouthful, but it's Small-Sided Games with Baskets Are Significantly More Effective at Enhancing Neuromuscular Force Parameters Compared to Ball Possession Games. A randomized controlled study in young male basketball players.
Very descriptive.
Very. And this rigorous work was conducted by JianChun, Wiradee, Eakronnarongchai, and Jakrin Duangkam.
It truly is a brilliant piece of literature. I mean, it brings this intense level of scientific clarity to something coaches and athletes do intuitively every single day.
Yeah.
The researchers took a highly dynamic, totally chaotic environment, the basketball court, and isolated the variables to show us exactly how the human body adapts to the precise tasks we ask of it.
We're not just looking at, who scores more points or who runs faster.
No, exactly. We are looking at structural, physiological changes in the muscles themselves and the nervous system.
Okay, let's unpack this for the listener. Think about your own workouts or, your own learning routines. If you run for 20 minutes aimlessly versus running for 20 minutes to catch a specific train before the doors close, your body and your brain react totally differently.
Oh, absolutely. The urgency changes everything.
Yeah, the effort might look similar on a stopwatch, but the physiological response, the way you move your joints, the urgency of those muscle contractions, it is distinct. Today, we're looking at the scientific proof of that concept, mapped out right on the hardwood floor.
Which means we need to talk about the primary tool these researchers used, which is small-sided games.
Right. We're moving from the big concept into a specific laboratory. So what exactly is a small-sided game?
So small-sided games, or SSGs, they're heavily utilized by coaches across almost every team sport, and for very good reason.
Is it safe space?
Well, partly, yeah. If you imagine a full 5-on-5 basketball game, it takes up a massive 94-foot court. But in an SSG, you shrink that environment, you condense the court space, so maybe playing only on a half court, and you reduce the number of players, typically running formats from 2 versus 2 up to 4 versus 4.
So it's essentially what you see at a local park on a Saturday afternoon. Just, pick up basketball.
Exactly. But in an academic training context, it becomes this highly controlled variable. Coaches love them because they simulate real game scenarios much better than isolated drills.
Like just shooting free throws.
Right. If you have a player just standing in a line waiting to shoot a layup, they're only practicing a closed motor skill. In a small-sided game, players are exposed to multifactorial stimuli. They have to process technical skills, tactical decision-making, spatial awareness,
and extreme physical demands.
all simultaneously. It's chaotic, sure, but it's a structured chaos that forces the brain into overdrive.
And the researchers in this study took that structured chaos and divided it into two very distinct rule sets, which they call task conditions.
Right, the basic group and the possession group.
Yeah, so both groups are engaging in these games on the exact same court dimensions, but their objectives are completely different. The first condition is small-sided games with baskets, or SSGBK. Here, the games target scoring in a basket.
The ultimate goal is just putting the ball through the hoop.
Right. But there's a massive catch in the rules. They explicitly stated that no three-point shots were allowed.
That constraint is incredibly important. By eliminating the outside shot, it forces the geometry of the game to shrink even further, which we will see plays a huge role in the data later on.
They basically banned long-distance shooting entirely.
Yep.
And then we have the second condition, which is small-sided games focused on ball possession, or SSGBPG. In these games, the baskets are just entirely removed from the equation.
It's just keep away.
Exactly. You play keep away from the defending team, and you score a point not by shooting, but by successfully completing 5 consecutive uninterrupted passes among your teammates.
So we have two groups of athletes playing in the exact same physical space for the exact same duration.
2 extra sessions a week, right?
Yeah, with rounds lasting between 2 and 4 minutes, separated by strict 2-minute rests. The volume of work is perfectly matched. The only difference is the visual target. Shoot the ball into a hoop or keep the ball away from the other guys.
Which, brings up a really natural question. If you are listening to this and mapping it onto your own gym routine, you're probably wondering, if both groups are on the same half court, running around, sweating, panting for the exact same amount of time, shouldn't their leg muscles be doing the exact same amount of work?
What's fascinating here is the vital distinction between cardiovascular exertion and neuromuscular demand.
Oh, okay. Let's break that down.
Well, if you were just measuring their heart rates or looking at the total distance they covered on a GPS tracker, you might assume the workouts were nearly identical.
Because they're both tired.
Right. But cardiovascular fitness is primarily about oxygen delivery, how well your heart and lungs pump fuel to the muscles. Neuromuscular demand, on the other hand, is about how your brain and nervous system tell those muscle fibers to fire, and with how much violent explosive force.
So it's about intensity of the movement, not just the duration.
Exactly. Maximum acceleration, rapid deceleration, maximum effort, vertical jumps. These are high threshold events. They require your nervous system to recruit every available motor unit in a fraction of a second. That is what actually dictates strength building.
And those high threshold events are dictated by the rules of the game being played.
Entirely. Not just the time spent sweating.
So to prove that the rules dictate the biology, the researchers couldn't just, rely on observation from the sidelines. They had to transition into some serious, highly rigorous methodology to measure these invisible physiological forces.
The rigor here is really something to appreciate. They recruited 50 regional competitive level male youth basketball players.
Okay.
Average age of 16.7 years, which is a crucial demographic.
Because they're already in shape.
Yes, they are well-trained, meaning they have a solid baseline of fitness. They aren't going to improve just from getting off the couch. But because they are teenagers, their nervous systems are still highly plastic and primed for neuromuscular adaptation.
So they divided these 50 players randomly into 3 groups: the basket group, the ball possession group, and a control group.
Right.
Just to clarify, the control group just did their regular team training, right? Nothing extra.
Correct. Meanwhile, the 2 experimental groups did their standard training, plus the 2 extra small-sided game sessions per week for 8 weeks.
And they were pretty strict about the timing, too.
Very. The experimental sessions occurred exactly 48 and 72 hours post-match. They did this to ensure every single player was uniformly recovered. No one was testing on tired legs.
But the most impressive part of the methodology, I think, is the tech they used to measure the outcomes.
Oh, absolutely.
They evaluated the players the week before the intervention started and the week immediately after it ended, using some highly sophisticated laboratory equipment.
Yeah, they used dynamometers equipped with 50 Hz sensors, specifically a system called the force frame.
Right, so they didn't just ask the players if their legs felt stronger or, have them do a few squats. They strapped them into isometric rigs and had them jump on highly sensitive force plates to measure their power down to the exact Newton.
Exactly. They measured isometric muscle strength. 2 key metrics here: unilateral isometric knee flexor strength, or KFS, and unilateral isometric knee extensor strength, KES.
Let's soften that terminology a bit so we can picture it. Unilateral isometric knee flexor strength. That is really just a fancy clinical way of saying they measured exactly how much raw braking power your hamstrings can generate on one leg when pulling against an immovable object.
That is a perfect translation.
And the extensor strength is just how hard your quadriceps can push.
Right. They are measuring absolute raw force generation. But they didn't stop there. They also used VALD force decks, which are these incredibly precise dual force platforms, to measure dynamic movement.
Like jumping.
Yes. They had the players perform a counter movement jump test, or CMJ. That is where you stand perfectly still, dip down quickly, and jump as high as you physically can.
And the plates measure that.
The force plates measure the peak power generated during the takeoff, and crucially, the peak landing force when the player hits the ground.
And they also did a single leg land and hold test, right? The LHT.
Yep, where the player drops off a box onto one leg and has to stabilize immediately. Again, the plates measure that peak drop landing force.
So I'm trying to visualize this from the perspective of an athlete, or really anyone trying to connect the dots to their own body. Why focus so intensely on these specific variables? Like, why do knee flexors and single leg landing forces matter so much?
Because in basketball, and truly in most field sports, these variables are the foundation of athletic performance and longevity.
The engine, basically.
Exactly. Knee extensor and flexor strength directly correlate to sprint speed, your first step acceleration, and your vertical jump height. But equally important is injury prevention.
Right, coming down from a jump.
When a player lands from a rebound or decelerates rapidly to change direction, the knee joints experience massive shear forces. High neuromuscular capacity allows the muscles surrounding the knee to absorb that kinetic energy safely.
And if they can't absorb it,
Then the force transfers directly to the ligaments, which leads to devastating injuries like ACL tears.
wow. Okay, so we have these players executing two totally different game plans for 8 weeks. The stakes are high, injury-wise and performance-wise. The question is, does the nervous system actually care about the rules of a game?
And the answer is yes.
A resounding yes. When they strapped these kids back into the force plates 8 weeks later, the way their bodies adapted was completely asymmetrical. The divergence in the results is honestly dramatic.
It really is. I mean, the term statistically significant gets thrown around a lot in academic papers, but the effect sizes in this study were massive.
The winner, without a doubt, was the group that played with the baskets.
The SSG Beacon group saw incredible neuromuscular improvements across the board.
Let's look at the specific numbers because they paint a very vivid picture. For knee extensor strength, again, the basket group jumped to an average of 287.7 newtons of force post-intervention.
Which is huge.
To put that into perspective for our listener, 287 newtons is roughly enough force to lift a 65-pound weight with just a single leg extension.
Right. And the keep away group, the ball possession guys.
They ended up at only 231.7 newtons.
That is nearly a 24% difference in raw power, generated purely by changing the rules of the game.
Just wild. And we see the exact same pattern in the knee flexor strength, the hamstrings and calves.
Yeah?
The basket group increased to 363.7 newtons, while the possession group lingered way back at 312.2 newtons.
Furthermore, the basket group also saw significant increases in their counter-movement jump peak power. They were literally producing more explosive energy per kilogram of body weight than before the 8 weeks began.
But then there's the surprise in the data. We talked about peak landing forces. For the basket group, the peak landing forces in both the counter movement jump and the single leg land and hold tests significantly decreased.
Which seems counterintuitive.
Right. Wait, hold on. I get why their power went up because they are jumping more, but wouldn't jumping more often and jumping higher in a crowded space lead to harder impacts? Why did the landing force go down?
That is the paradox of the study,
Yeah.
and it is brilliant. But before we explain why, we have to look at the loser of the experiment, the ball possession group.
Oh, right.
The data showed virtually no significant neuromuscular differences between them and the control group, who did no extra work at all.
Here's where it gets really interesting. Are you telling me that the group playing keep away essentially got zero extra strength benefit?
Basically, yes.
They basically just got a sweaty cardio workout while the basket group got a full-blown strength and conditioning session. How does simply adding a metal hoop to the court rewrite human physiology to that degree?
This raises an important question, and it's really the crux of the entire deep dive. To understand how a metal hoop changes biology, we have to look at the biomechanics and the behavioral shifts that the rules of the game inherently force upon the players.
Okay, let's break it down, starting with muscle activation.
Yes. When the goal is to score a basket, players are forced to execute maximum effort vertical jumps. Whether it is elevating over a tall defender for a layup or fighting for a rebound off the rim, reaching the basket demands high levels of force.
Right, you can't just lightly jog into a rebound. You have to explode upward or you lose the ball.
Exactly. And that explosion requires massive recruitment from the quadriceps to extend the knee and the hamstrings and gastrocnemius muscles to flex and stabilize.
So doing that over 8 weeks.
It promotes deep neuromuscular adaptations. The nervous system learns to synchronize those motor units more effectively. It is essentially your brain learning how to fire all of its muscle fibers at the exact same millisecond, resulting in the increased isometric strengths they measured on those dynamometers.
And that ties directly into the increase in their jump power, right? The study references something called the stretch shortening cycle.
Yes. Think of your muscles less like a car engine and more like a bow and arrow.
Okay.
When you dip down right before a jump, your muscles stretch, drawing the bowstring back. The basket-oriented games forced these players to fire that bow over and over again.
And this constant repetition enhances the efficiency of the stretch shortening cycle.
It actually increases the stiffness of the muscle tendon unit, making that bowstring tighter, and improves neural activation. The result is that the players optimize their power output. They become better, more violent springs.
Okay, that makes perfect sense for why their power skyrocketed. But we have to address that paradox we mentioned, the landing force. Why did their landing force actually decrease?
That is where the specific constraint of the task condition becomes so important. Remember, the rules of the basket game explicitly eliminated three-point shots,
Right, no outside shooting allowed at all.
which completely changed the geometry of the game. It forced all the action into the paint, directly underneath the basket.
A lot of traffic.
It forced close-range combat, contested layups, and heavy traffic for rebounds. This meant the players weren't just jumping, they were jumping in a crowded space, bumping into each other, and landing constantly.
And this high frequency of exposure to unstable landing impacts acted as a catalyst for a massive behavioral change.
Their bodies basically had to adapt or break down.
Right. They developed enhanced proprioception.
Yes. Proprioception is the body's subconscious awareness of its position in space. Every time they landed in that crowded paint, their brain was doing subconscious calculus.
It felt the sheer force on the knees and the ankles.
And because they were landing so often, their nervous systems unconsciously refined their landing techniques to protect the joints. The data suggests their brains literally rewired their motor cortex to increase their knee and ankle flexion upon touchdown.
Meaning they learned to bend their knees and ankles just a few degrees further when their feet hit the floor.
Yes. By bending their joints more upon impact, they elongated the deceleration phase. They distributed the landing forces more evenly across the lower extremities,
Which smooths out the force dissipation.
reducing the violent, abrupt peak forces that lead to joint injuries. It is a stunning example of neuroplasticity driven by environmental constraints. Jumping more often in traffic actually reduced the violence of their landings.
So what does this all mean? It's like the body's shock absorption system upgraded itself entirely on autopilot.
That is a perfect way to conceptualize it.
Because the specific rules of the game force them to brace for impact more often, their nervous system literally learned how to land softer.
It is an unconscious motor learning process driven entirely by the environment. And it beautifully explains why the ball possession group saw absolutely none of these benefits.
Let's look at them for a moment. They were playing keep away. To get a point, they had to string together 5 consecutive passes. So what behavior does that rule encourage?
It encourages continuous lateral movement, creating tactical spacing away from defenders, rapid changes of direction, and prioritizing the pass.
Looking for open space horizontally, not vertically.
Exactly. Players are looking for space on the floor, not fighting for vertical space in the air. While this is fantastic for aerobic fitness, cardiovascular endurance, and spatial awareness, it fundamentally lacks the specific stimulus required for neuromuscular adaptation.
Because there are very few explosive maximum muscle recruitment events in a game of keep away.
You don't need to jump at maximum capacity to complete a chest pass. Your brain never has to recruit every motor unit, and you're rarely landing from a maximum effort jump. So your proprioception regarding impact never gets upgraded.
If we connect this to the bigger picture, training must be meticulously matched to the biological adaptation the coach or the individual actually wants.
Absolutely.
You can't just put athletes on a court, make them sweat, elevate their heart rate, and assume they are getting stronger and more explosive.
Exactly. The stimulus determines the adaptation. The researchers highlight this as the primary practical application of their study.
Right.
If a coach wants to improve a player's cardiovascular base or their passing vision under pressure, the ball possession games are excellent, highly effective tools.
But if the goal is to build explosive power,
If the goal is power, increasing knee strength, and training the nervous system to absorb landing impacts safely to prevent ACL, TLC, Tier's ball possession games are effectively useless. The coach must utilize basket-oriented games. The presence of the hoop and the rules constraining the players to attack it are non-negotiable for that specific physiological outcome.
it's a profound takeaway that extends far beyond the basketball court. Task conditions dictate biological adaptations. What you ask your body to do, down to the exact environmental constraints you place upon it, determines how your biology will rewire itself.
It's powerful stuff.
For the coaches, the athletes, or anyone just trying to design a better workout listening right now, the message is clear. Carefully select your drills. Use basket-oriented games in smaller spaces when you want high-level neuromuscular engagement, explosive power, and injury-preventing landing mechanics.
And reserve your ball possession games for building aerobic capacity and refining tactical passing skills.
It is a strong reminder that we must be intentional with our design. We often think of strength training and injury prevention as something that, only happens in the weight room with barbells and squat racks.
Right. But this study proves that with the right rules, the playing field itself becomes a highly effective neuromuscular training ground.
It is truly fascinating research. For anyone who wants to look at the exact formats the researchers used or see the complete statistical breakdowns from the force plates and dynamometers we discussed today, I highly encourage you to go read the full article by JianChun, Wiradee, Eakronnarongchai, and Jakrin Duangkam.
The methodology alone is worth reviewing if you are at all interested in sports science research design.
Absolutely. Again, you can find it published in the 2024 edition of the Journal of Sports Science and Medicine. It is presented with incredible scientific clarity and is a deeply rewarding read for anyone interested in the hard science of human athletic performance.
Definitely go check it out.
And to you, the listener, if you enjoyed this level of scientific clarity and want to continue unpacking the research that explains how we function, adapt, and perform, please make sure to follow the channel and turn on your notifications. We have a lot more material to cover in the future.
Lots more deep dives coming.
But before we go, I want to leave you with a thought that brings all of this back to your own life. We've seen today how running aimlessly compared to running toward a distinct target changes everything. If the simple presence of a visual target, a basketball hoop, can fundamentally alter the way human muscles fire and absorb impact, how might changing the specific visual goals in your own daily workouts or even your learning routines completely rewrite your physical and mental results?